linear search. It is a very basic and simple search algorithm. In this linear search algorithm, we will search an element or a key value in the given array by traversing the array from the starting until the desired element is found or value is found. So until then we will just traverse one by one in a sequential manner. That's why the linear search is also called as sequential search algorithm. So this is the linear search algorithm. So that means the step-by-step procedure how we will find a particular element. So the step 1 is we need to traverse the array using for loop. So in every iteration, compare the key element with the current value of the array. So we know array means it consists of n number of similar elements, means grouping up of homogeneous element. So each and every current value is compared with the key element. So here we have two cases are there. One is if the value is matched, that means the key element is compared with the particular value of the array. So if the both values are same, that means the desired target element is matched with the current value of the array, then it returns the current index of the array. So what is the index of array? For example, a of 2. A of 2 is the array. So it consists of two elements. So for example 0 and 1. So we will consider the two elements as 15 and 22. So if the array consists of two integer type values 15 and 22. Now what is the index of this one? Mean 0, 1. So 0 and 1 are called as the index of the arrays. So if the value is matched, for example if you find the key element as 15, so the key element is compared with the elements of the array. So first it need to compare from starting position. So the key is 15 and the current value of array is 15. When both the values are compared, the value is found here. So simply it returns the index as 0. So some cases if we want to find the value of 25, so the 25 is the not found in the array. So that is the second case. So the second case is if the value do not match, then we will move on to the next element of the array. For example, the first element is not matched with the key element. Then what we will do? So we simply move to the next element. So again next element is compared with the key element. So that element is also not matched. Then again move to the next element. So like that we will move to each and every element in the array until the last element is reached. So for example if no match is found, that means we are traversing from starting element to last element. Even though the last element is reached and that element is not matched with the key element, then simply it prints element is not found. So this is the linear search step-by-step algorithm. So we'll see the code how we will write. So simple logic. So simple logic is we need to consider the loop. So here the looping for loop is considered and we are considering two variables. One is I, another one is n. So here n represents n represents the total number of elements in the list and I is nothing but the index value. So n is total number of elements in the array and I represents the index value of the array. So now here for I is equal to 0, I less than n, I plus plus. So whatever working principle of linear search, it need to search from the starting element to the last element. It's simply traversing from first to last. And each and every value is compared with the key element. So here another variable is also considered, that is called as key. So key is nothing but our desired element or target element. So now once the loop is entered, so we need to compare the value. So here if a of I double equals to key, that means whenever the I value is 0, the index is like this. I will show. A of 0. A of 0 is nothing but the first element. Now the element in the index 0 is now compared with key. So for example, if the key value is matched with the first value, first element in the index, then it simply prints element found at index %t. So for example, if the element is not found, then what will happen? It simply increment the value by 1. The index value is incremented by 1. Now the 0 value is incremented to 1. That is A of 1. Now A of 1 is compared with the key element. If for example here the element is found, then simply it will print the value. It will print the index of that particular value. If the element is not found, again it will be incremented. So like this, the process is continued until the condition satisfies. That means I less than n. So once the condition is failed, then simply it will return back. And here we have a case that is called as break. Why we use this break? So what is the purpose? I'll show this one by using an example. Let us consider this example. Suppose an array A of 10. So here the name of the array is A, and total number of elements in that array is, the array size is 10. So here the array 10 consists of 10 elements, that is 2, 5, 25, 29, 16, 22, 9, 14, 28, 78. Now we are finding the key element, that is 22, by using linear search algorithm. So this is the question. Now we need to find the 22, whether it is available in the list or not. So for that we are using the step-by-step procedure of the linear search algorithm. So what is the first case? So we need to arrange the array of elements and we need to find the key element 22. So by using linear search, first we need to traverse from starting element. So here the starting element is A of 0. That means the key value is 22. Now key value is compared with A of 0, that is 2. So here the 2 value is not equal to 22. That means the element is not found at index 0. So what is the case now? It need to move to the next element of the array. Now it is moving to the next element, and that next element is compared with the key element. So like this. So what is the next element here? 5 is the next element. So what is the index of 5? A of 1. A of 1 is the position of 5 and 1 is the index. A of 1 is the address. So here 1 is the index of 5. Now, so 5 is not matched with 22. Then it will move to the next element. So the next element is 28. Now 28 is compared with 22. So here also not found. So element is not found here. So what it will do? Again it will move to the next element. So now the key element 22 is matched with 29. So 29 is not matched with 22. So again it will move to the next one. Simply the I value is incremented every time. So now the I value is incremented, and here at index 4 the 16 is compared with the key element 22. So here is also not found. Then simply it will move to the next element. So when it moves to the next element, here the value is 22 and the key element is also 22. So simply it will replay, means it will send the result as element found at index 5. Why index 5? So here is 0, 1, 2, 3, 4, 5. So at index 5 the element is found. So whenever the element is found, then simply the code will execute, means it will come out of the loop. But what will happen? Even the element is found, the code will not be coming out. It will again search for the element. So for stopping the code, means for coming out of the loop, we simply write down the break statement here. So whenever the element is found, simply we will break it. So simply we will write break. So whenever the element is found, simply we break the condition, because unnecessarily it is verifying the condition, because here the for loop condition is I less than n. That means even though the element is found at middle of the list, it will be searched up to the condition I less than n. So to stop that one, we simply write down the break statement within the loop whenever the element is found at a particular index. So this is one of the case. Another case is, even though the element is traversed, means the loop is run until the condition is satisfied. That means when I equal to 0, it will check whether the index value is the value at particular index is matched with the key or not. So if it is not matched, it will move to the next element, it will move to the next element, it will move to the next element, like that until the condition I less than n. That means if we have 10 elements are there, up to 10 elements it will continuously checking the key element. So even though the 10 elements are over, then what we'll do? So when the condition is failed, that means when I less than greater than, so total number of elements are over, in that case simply when the I value is equal to n, it will print element not found. So after I less than n, again the value is incremented. In that case the I value is equal to n value. So whenever the I value is equal to n, then simply it will give the printing value as element not found. So this is the case we will follow in the linear search algorithm. So we'll see the time complexity of linear search. So we have best case, worst case and average case. So best case is order of 1, worst case is order of n, average case is order of n plus 1 by 2. So how we will get this best, worst and average case? So first we will consider the best case. So best case is order of 1. Why? If we have 3 elements are there, 3, 4, 16, then our key element is 3. So if we have a list of 3 elements are there, or n number of elements are there, and the key element is for example 3. Now by using the linear search, firstly we have traversal from the starting element. That means 3 is compared with this key element 3. So at the index 0 itself only we found the element. That means in one step, means in one iteration we are getting the data. So that's why the best case is order of 1. Means in single step we found the data. That's why the best case is order of 1. Worst case. So what is worst case? So for example, here the data element or the key element is 16. If you want to find the 16, then what you will do? So first you need to compare with the first element, next you need to compare with the second element, next you need to compare with the third one. That means the last element is matched with the key element. Then that is the worst case, because the element is found in the list but it is located at the last element. So for that we need to take the n number of steps, because we have n number of elements are there in the list. So to found that element we need to traverse from first to n elements. So that's why the worst case time complexity is order of n. Now coming to the average case. So what is this average case? So for example, if we have n number of elements are there, so to found the key element at first position, it will take 1. And for second position means if the key element is located at the second position, that is 2. For finding the element which is located at 3, the time complexity is 3. So like that we will find the n number of elements, means in the worst case we will find the n number of elements at n, 1, 2, 3, so on n. So average case, what is the formula for average case? Mean sum of all the cases, sum of all cases by total number of cases. Total number of cases. So here by using this formula, the sum of all cases, that means first the element is found at 1, that is 1. The element which is found at 2, that means it needs 2 steps, and 3, like that up to n. So sum of all cases means we have 1 plus 2 plus 3 plus 1 plus 2 plus 3 plus so on n by total number of cases is n. And we have the formula for sum of n numbers. So what is the formula for sum of n numbers? N into n plus 1 by 2, and by 2 is there, so we'll write 2. So n mean the denominator and numerator n's are cancel each other. So now we have n plus 1 by 2. So that is the average time complexity of linear search algorithm. Thank you.